Okay, so guys, in this video we have to analyze the derivatives of hyperbolic functions. So I will make a separate video on hyperbolic functions, but for now let's just discuss the derivative of these hyperbolic functions. So if we have the derivative of sine hyperbolic x, it is actually equal to the cos hyperbolic x. It is actually very simple because the derivative of sine x was also equal to cos x. Okay, so the derivative of sine hyperbolic x is equal to cos hyperbolic x, and the same thing, the cos hyperbolic x would be sine hyperbolic x, then the tangent hyperbolic x would be equal to secant hyperbolic square x. Cosecant hyperbolic x would be equal to negative cosecant hyperbolic x multiplied by cot x. Then the secant hyperbolic x would be equal to negative secant hyperbolic x dot tangent x. Okay, I think this is actually very uncommon because in other derivatives, in the simple derivatives, we were having this thing as positive, but over here we are having it negative. So anyways, the derivative of cot hyperbolic x is actually equal to negative cosecant hyperbolic square x. And you can access the PDF of these formulas from the description of the video. Now let's practice some examples. So we have to find the derivative of cos hyperbolic 2x. Okay, so we know that the derivative of cos hyperbolic x is equal to sine hyperbolic x, but over here instead of having x I have 2x. So wherever I'm having x, I have to replace it with the thing which is given to me. Okay, so it would be equal to sine hyperbolic, okay, same thing, but over here it is x. We have 2x, so we have to write 2x and multiplied by the derivative of the function of the cos hyperbolic. So what is the function of cos hyperbolic? Of course 2x is the function of cos hyperbolic, so we have to take its derivative, so 2x. So sine hyperbolic 2x multiplied by 2 is a constant, so it would be separated, d by dx, x cancelled, we are left with sine hyperbolic 2x, and this 2 can actually be written over here. Okay, so the derivative of cos hyperbolic 2x is 2 sine hyperbolic 2x 3x, and you have to find the derivative. So first of all, let's just apply the differentials on both sides of the equation. I have done a mistake in the previous question if you compare it with this question, because I have to apply the differentials on both sides of the equation. Okay, so cos hyperbolic 2x, this was the step which I just missed. We know the derivative of sine hyperbolic x is equal to cos hyperbolic x, and again we have to replace it with x. So instead of writing cos hyperbolic x, I will write cos hyperbolic 3x, because for my situation x is actually 3x multiplied by the derivative of the angle. What is the angle? It is 3x. Now you can call this thing as an angle, or you can call it a function of cos hyperbolic. Okay, so if we translate it into the derivative terms, it would be the derivative of the function of the cos hyperbolic, or it would be the derivative of the angle. Okay, so anyways, basically you have to take the derivative of anything which is present inside the bracket. Okay, so cos hyperbolic 3x multiplied by 3 would be separated and dx would be cancelled, so we are left with 3 cos hyperbolic 3x. So this is the final derivative. Okay, so we have the derivative, we have to find the derivative of cos hyperbolic x cube. Okay, so we know that the derivative of cos hyperbolic x is sine hyperbolic x, and then you have to of course take the derivative of the angle, right? So for our case x is actually x cube. So let's just take the differential on both sides of the equation. So over here we have x, right? So we have to replace it with sine hyperbolic x cube multiplied by the derivative of the angle. So what is the angle? It is the thing which is present inside the bracket, that is x cube. So d by dx x cube. So what would be the derivative of x cube? It would be, power would be separated, the function, then the power minus 1, 3 minus 1 is actually equal to 2. So the derivative is 3 sine hyperbolic x cube multiplied by x square. So we have to find the derivative of y is equal to secant hyperbolic x power 4. The derivative of actual secant hyperbolic x is negative secant hyperbolic x multiplied by the tangent x. Okay, so let's just apply the differentials on both sides of the equation. So instead of writing x, we will replace it with x4. So we have negative secant hyperbolic x4 multiplied by tangent. Instead of writing x, we will write x4. So tangent x4, and again the derivative of the function. What is the function? It is the thing which is present inside the bracket, that is x4. So the derivative of x4. Okay, so we have negative secant hyperbolic x4 multiplied by tangent x4. Now what would be the derivative of x power 4? Power will be separated, then the function as it is, then the power minus 1. What is the power? 4 minus 1 is cube. So we have negative secant hyperbolic x power 4 tangent x power 4 x cube. The 4 would be written as a constant. Alright guys, over here we have two functions, okay, and those two functions are actually being multiplied. So this is the first function, okay, fx, and this is the second function, gx. And we know this thing, when we are giving two functions which are being multiplied, we can use the product theorem right over here. So what the product theorem says, if you have two functions which are being multiplied, i.e. fx and gx, you can use the product theorem, which is the second function as it is derivative of the first function plus the first function as it is derivative of the second function. So over here, our first function, i.e. fx, is x squared, and the second function, i.e. gx, is sine hyperbolic x. Okay, so we can use this formula. So let's just apply the differentials on both sides of the equation. So the second function as it is derivative of the first function, i.e. x squared, plus the first function as it is derivative of the second function, that is sine hyperbolic x. So the sine hyperbolic x would be as it is, the derivative of x squared would be 2x because the power will be separated, the function will be as it is, and then the power minus 1. So what is the power? It is 2. Minus 1 would be 1. So we don't usually write 1, of course. X squared, the derivative of sine hyperbolic x is actually equal to cos hyperbolic x multiplied by the derivative of the function. What is the function? It is this thing right over here. So d by dx, x will be cancelled, and we are left with 2x sine hyperbolic x plus x square cos hyperbolic x, of course, multiplied by 1. You can write, or if you don't want to write, just don't write it. If you're confused at how can we separate this 2x right over here, actually you shouldn't be confused about it. But yeah, if you're confused, so these terms are actually being multiplied, so we can write them in any order. Okay, so now we have to find the derivative of 2 sine hyperbolic x plus 8 cos hyperbolic x. So of course these are being added, so we have to apply the differentials on both of these terms. Okay, then the derivative of 2 sine hyperbolic x plus the derivative of 8 cos hyperbolic x. Of course 2 and 8 are constant, so we can separate it. The derivative won't have any effect on it. So 2 plus 8 d by dx. What is the derivative of sine hyperbolic x? It is cos hyperbolic x. What is the derivative of cos hyperbolic x? It is sine hyperbolic x, and that's the final answer. Okay, so we have to find the derivative of 5 tangent hyperbolic x whole squared. Okay, so first of all, this is actually x, right? If we know we have things like x squared, so we can write 2x, right? Over here, this is my x. This thing is behaving as my x. So first of all, let's just write 2x. So 2, instead of writing x, we will write 5 tangent hyperbolic x multiplied by the derivative of the angle. Now what is the angle? It is the thing which is present inside the bracket. So the derivative of 5 tangent hyperbolic x multiplied by, so the 5 will be separated, the derivative won't have any effect on it because it is a constant, multiplied by the derivative of tangent hyperbolic x. So 2 multiply 5, we can actually multiply them, so 10 tangent hyperbolic x. So what was the derivative of tangent hyperbolic x? It is actually secant hyperbolic square x. So this is the final derivative of this question. Alright, now we have to find the derivative of y is equal to 27 cot hyperbolic x plus 7 minus sine hyperbolic x. Of course, these terms are being subtracted, so we have to apply the differentials on both of these terms. So the 27 will be separated because it is a constant, d by dx cot hyperbolic x plus 7. Now we know that the derivative of sine hyperbolic x is actually cos hyperbolic x, but we cannot write it right now because we have to simplify this thing first of all. Okay, so d by dx sine hyperbolic x. The derivative of cot hyperbolic was, now if you see the derivative of cot hyperbolic x, okay, over there we have x plus 7. The general formula actually says the derivative of cot hyperbolic x is negative cosecant hyperbolic squared x. So instead of writing x, we will write x plus 7, and of course we will take the derivative of it. So we have to write negative cosecant hyperbolic square. So instead of writing x, we will write x plus 7. Then we have to take the derivative of the angle. What is the angle? This thing right over here, x plus 7 is our angle for this function. Minus the derivative of sine hyperbolic x is obviously cos hyperbolic x. Cosecant hyperbolic square x plus 7. The derivative of x plus 7 is 1 because the derivative of x is 1, but the derivative of 7 is 0 because it is a constant. Okay, so the derivative of this entire thing would be 1 minus cos hyperbolic x. So we can write this negative sign will be with the 27 constant. So we have negative 27 cosecant hyperbolic square x plus 7 minus cos hyperbolic x. Okay, so guys, we have to find the derivative of 4 secant hyperbolics multiplied by Euler 2x. Euler 2x is actually the angle of this secant hyperbolic. So let's just apply the differentials on both sides of the equation. So 4 will be separated because it is a constant, the derivative won't have any effect on it. The derivative of secant hyperbolic is negative secant hyperbolic x tangent x. So instead of writing x, we will write Euler 2x because that's our x for our question. So negative secant hyperbolic Euler 2x multiplied by the tangent Euler 2x and then the derivative of the function. What is the function? This thing right over here. So the derivative of Euler 2x for minus secant hyperbolic Euler 2x tangent Euler 2x multiplied by what is the derivative of Euler 2x. Now if you haven't studied the derivative of Euler or the exponential functions, you can watch those videos. I have just covered them in the previous videos, so you can watch them. The derivative of Euler 2x, because 2x is actually a function, okay, f of x, so we have to it would be as it is first of all, then we have to take the derivative of the exponent. What is the exponent? That is 2x. So we have 4 minus secant hyperbolic Euler 2x multiplied by tangent Euler 2x multiplied by Euler 2x. Now what would be the derivative of 2x? Of course it would be 2 because x is it would be cancelled by 1, so we are left with a 1 anyways. 2 will be multiplied by 4 and we are left with 8 minus secant hyperbolic Euler 2x multiplied by tangent hyperbolic Euler 2x multiplied by Euler 2x. Okay, so this is the final derivative. Okay, so we have to find the derivative of 12x power 5 multiplied by cos hyperbolic 9x. Okay, so let's just apply the differentials on both sides of the equation. Of course 12 is a constant, so we can just separate it from the differential. Now hyperbolic 9x is a hyperbolic function and x power 5 is an algebraic function, so we have two different types of functions. When we have two different types of functions, we can use the product theorem. So this is the product theorem. It's the second function as it is derivative of the first function plus the first function as it is derivative of the second function. For my situation, x power 5 is fx, the first function. Cos hyperbolic 9x is gx, the second function. So we can just simply find the derivative now. 12 will be separated and we'll use a square bracket to separate it from other things. So the derivative of the second function, cos hyperbolic 9x multiplied by the derivative of the first function. What is the first function? X power 5. The first function as it is x power 5 multiplied by the derivative of the second function, that is cos hyperbolic 9x multiplied by what would be the derivative of x power 5. So first of all the power will be separated, then the function as it is, the function is x actually, and the power will be subtracted by 1. So 5 minus 1 is actually 4 plus x power 5, the derivative of cos hyperbolic 9x. Now the derivative of cos hyperbolic x was sine hyperbolic x, so we have cos hyperbolic 9x, so the derivative would be sine hyperbolic 9x, and of course the derivative of this angle right over here, it would be 9x. So we have 12 cos hyperbolic 9x multiplied by 5 x4 plus x5 sine hyperbolic 9x. What would be the derivative of 9x? It would be 9 because the x will be cancelled and we are left with a 9. You can multiply these this 12 inside, so we will be left with 12 multiplied 5 will be 60. X power 4 cos hyperbolic 9x plus 12 multiplied 9 gives us 81. X power 5 sine hyperbolic 9x. Okay, so this is the final derivative. So we have to find the derivative of cosecant hyperbolic natural log of x. Okay, so let's just apply the differentials on both sides of the equation. Natural log of x is actually the function of cosecant hyperbolic x. It is present inside the bracket of these, cosecant hyperbolic x. What is the derivative of cosecant hyperbolic x? It is negative cosecant hyperbolic x multiplied by the coth hyperbolic x. So we can write negative cosecant hyperbolic multiplied by coth hyperbolic. What is x? It is natural log of x multiplied by the derivative of the function. What is the function? It is natural log of x. Okay, so we have negative cosecant hyperbolic natural log of x multiplied by coth hyperbolic natural log of x. What is the derivative of natural log of x? It is 1 divided by x. So we can simply write 1 divided by x with a negative sign, cosecant hyperbolic natural log of x multiplied by coth hyperbolic natural log of x. So this is the final derivative. Okay, so the final question of the day, we have to find the derivative of 7x plus tangent 3x. So we can simply apply the differentials on both sides of the equation. The 7 will be separated because it is a constant and the derivative of x is, we are left with 1 of course. The derivative of tangent hyperbolic 3x. Now the derivative of tangent hyperbolic is secant hyperbolic squared x. Okay, so secant hyperbolic squared, instead of writing x I will write 3x multiplied by the derivative of the function. What is the function? It is 3x. So you have 7 plus secant hyperbolic squared 3x. Now x will be cancelled and we are left with 3. So we have 7 plus, we can write this 3 over here. So 3 secant hyperbolic square 3x. So this is the final derivative of our function.